So we'll wait for 5 more minutes, then we'll start. Kartika, are you ready?
Yeah, I'm ready.
Yeah.
Karthika? We will be starting in a few minutes. Pratik, are you ready?
Yes, I am.
Okay, great. So in few minutes we'll start because I guess some participants are still joining. So we'll Maybe Karthika, I guess we can start it off.
Yeah, okay.
Yeah, you're looking graceful. Great, we can start.
Yeah. Hi guys, welcome back to a second session of the day, which is a hands-on workshop. And I would take the opportunity in introducing our speaker, Mr. Pratik Garai, who is a dedicated computer science engineering student with a focus on AI and machine learning. He's worked on a number of projects in the domain of NLP, federated AI, computer vision, web development, blockchain, robot programming, etc. Apart from that, he devotes time to numerous clubs at the undergraduate level. Please welcome Mr. Pratik Garai. You may please take over.
Thank you, Karthika, for the introduction. Hi guys, I'm Pratik. I'm a third year student at VIT Chennai, and I'll be taking you through a hands-on session of deep learning. So I'll just share my screen now. Okay, so guys, is my screen visible? Can someone confirm?
Yeah, it's visible, Pratik.
Yes, it is.
Okay, guys, so good evening and welcome. First of all, thank you guys for joining me in this session. So today, what we are going to see is how deep learning can be used for image classification. So image classification as in like we'll give our AI an image and it will tell which category it belongs to. And the particular use case is going to be pneumonia recognition using the X-rays of chest. So what we are going to do is we are going to train our AI by giving it examples first. We'll teach it through examples. We'll give it a few images of chest X-rays which belong to people who were normal. And then we'll give it some examples of chest X-ray images of people who had pneumonia. And the machine learning model or the AI model will train itself to distinguish between the two. And eventually, if we give it even an unknown image, it will be able to tell which category it belongs to, whether that person has pneumonia or not. So before we move on to like the demo, I would like to ask Yashaswini, can you pass the Google Colab link to the people in the chat box?
Yeah, sure.
Okay, so I'll be using Google Colab as a running environment because Google Colab is cloud hosted. It comes in with GPU, so the training will be a lot faster. And apart from that, most of the libraries that we need, machine learning libraries, all the popular ones are pre-installed inside the environment. So you guys don't have to worry about, setting up the entire environment. And it connects very well with your Google Cloud. So if you have like data stored in your Google Cloud, or if you want to save your model in the Google Cloud for easy transfer, all of it can be done pretty easily. So, okay, so soon you guys will be given a link to this, to the notebook that I am using, and you guys can save a copy of it by going to files, and you'll get an option of save a copy in Drive. And that will take you to a new window, a window which you can edit. So while I am going through this entire demo, you guys can side by side execute the same thing, and you guys can also, play around with a few values and test out in the meantime, or maybe after the demo is over. So before we go into like the demo, I'll first like to introduce you to artificial neural network, the model that we are going to train. A kind of theoretical introduction to it. So an artificial neural network looks somewhat like this. So even before going there, I would like to first discuss how machines can be used to solve problems. So as a programmer, whenever I'm asked to solve a problem, whenever I'm given a question, there are basically three ways in which I can solve a question. So the first one is computational programming. So in this in this domain or in this subcategory fall problems to which we have definite answers, to which we have 100% accurate solutions. As in, like, imagine if someone asks you that, you are given a temperature in Fahrenheit and convert it to Celsius. We all know the formula and it does not change. It is 100% accurate. It is like, no matter whichever environment you take it to, it will hold. Or imagine someone asks you to, calculate the force needed to move somebody. The formula is going to be the same. It is well known, right? But there are some problems to which definite answers do not exist. Like suppose you know that there is this house, it has these many number of rooms, it is in a region where the average income is something, and like it has a backyard, it has a pool, and someone has asked you to predict its price. Now there is no way that you can get, a formula which fits to all the houses in the world, let alone all the houses in the world. You cannot even do that for all the houses in the locality, right? You cannot get 100% accurate formula, but you can do an approximation that will be like somewhere, around maybe 1 lakh apart from each other. So in those cases, the number of rooms, the features, the inputs that you're getting, that the number of rooms, the presence, whether there is a pool or not, whether there is a backyard or not, all of these, they hold a direct significant, direct significance to the output. If the number of rooms are more, if the land area of a house is more, then definitely the price is going to be more, right? So in this case, we know that the inputs are going to affect the outputs, but we don't really know how much they will affect the output. In that case, we go with machine learning. And in machine learning, we go to the subdomain of statistical machine learning. So you guys might have heard of linear regression. Then you guys might have heard of decision tree, random forest, SVM. All of them fall under the statistical machine learning model. They use pure mathematics. They have like fixed mathematical models. You feed in the data and they will automatically calculate this weightage, like how much an input affects the output. But then there comes a third level of problems, that someone gives you the image of a dog or a cat and tells you to identify what animal it is. Now, we know that the pixels, we are observing the pixels, and the pixels are affecting our brain to, identify whether it's a cat or a dog. But I cannot definitely say that, okay, this pixel, if this pixel is brown, or if this pixel is black, or if this pixel is of this value, then it is a cat, it is a dog. Or if here I have a shape like this, then it is a cat or it is a dog, right? It's way more complicated than that. We know there is a relation, but we don't even know how that relation is affecting, whether it's increasing effect, decreasing effect. In that case, we use neural networks. So neural networks will help us approximate even non-linear functions by themselves. We don't even need to worry about it. We just feed in the data and it would automatically calculate if it has the capacity to do so. If it is extensive enough, then it can find out the relation between everything automatically. So the basic artificial neural networks looks somewhat like this. It consists of nodes. Okay, so before that, Akshay, is my cursor visible, like mouse cursor?
Yes, it is visible.
Okay, yeah. So you can see these circles. Each one of these circles, they denote a neuron. We'll come to the structure of neuron later, but just for now, it consists of a network of neurons. On one hand, we have a few inputs. Each one of these inputs will receive one feature. A feature as in, like we considered the problem of a housing price prediction, right? So maybe the number of rooms will go inside one area. The whether it has a backyard or not, yes, no, will go here. Whether it has a swimming pool or not, yes, no, will go here. And simultaneously, like based on how many features we have of the input, how many features we want to consider, we'll have the number of input nodes here. And then they will pass in through a hidden layer. This hidden layer here, it has been shown as just one layer, but actually it's in most use cases, it has like multiple layers of hidden layers. Like there could be 5, there could be 6, then there could be 7 layers, and all of them would be interconnected. And that part will fine tune itself based on the examples that's given. That part will fine tune itself to find the weights which are the most suitable for our problem. And finally, we'll have the output. And now coming to the structure of a neuron, what happens inside a neuron is once we give in an input, it's going to multiply the input values to a weight array which is present inside the neuron. and then it is going to add it to a number called bias. Now this bias is also a changeable parameter, and it's added like if you guys know, like you guys might be familiar with linear equations, right? So it's of the form like y equals to mx plus c, or if it is if you're taking a second degree, it is ax square plus bx plus c. So that last constant term, which is not dependent on any of the inputs, that is the bias term. So it adds it to a bias, and then it passes it through an activation function. Why do we need this function? Because if we do not use this activation function, the entire model will act like a big, interconnected, dense linear network. It won't be able to identify non-linear patterns inside the data. So we pass it through an activation function, which in most cases is non-linear, and then we get a prediction. And this prediction, we compare it to the expected value during the training phase. We compare it to the expected value, and we see whether our prediction was higher or was it lower than the expected value. And based on that, we will fine tune the weights, the W that was present inside it, the weight that was present inside it, and the bias, until we are able to minimize that error. So here we have an example of the matrix multiplication that I just said. So let's take an example where we have like 4 inputs and we have 3 hidden layers. Okay, like in a hidden layer, we have 3 nodes. So this is just one layer with 3 nodes. So the calculation inside the that layer would look somewhat like this. We would have a 3x4 matrix. So why do we need a 3x4 matrix? Why exactly this shape? Because you can see each neuron, like each neuron here is connected to all the neurons of the previous layer. So we have 3 neurons in the current layer. So that is why we have 3 rows, and we have 4 neurons, 4 connections. Each neuron is connected to 4 neurons of the previous layer. So we have 4 columns, and that is multiplied to the input that comes in as x1, x2, x3, x4 as a series of x1, x2, x3, x4. And we get like 3x4. If we multiply it to a 4x4 matrix, we get another 3x4 matrix, and then we add it to this bias term. And therefore, and by adding it to the bias term, we get these observations. So this is going to be our output. So up till here, guys, do you have any doubt? I mean, it would be a bit, hard to understand at first, but do you guys have any doubt in the overall structure of the neuron? Anyone? Okay, fine. I think
no doubts, it's easy. We understood.
Okay, fine. Okay, so now let's move on to the main hands-on area. So, well, okay, it says runtime disconnected because it was idle for a long time. Let me reconnect it. Yes, so my connection has been made. Fine.
I have a doubt in this.
Yeah.
So each colored unit or circle is a neuron, right? Which
Yes.
is connected to the these are the inputs
Yes.
given by the person.
Yes.
Okay. So these inputs intercommunicate with these neurons and generate output. Am I right?
Yes.
Hello.
Yeah. Am I audible?
There is some interconnection, internet connection to in my phone. Some problem.
Okay. Well, okay. I said yes. They interact with the input and then they generate the output by multiplication. It's like normal multiplication, and then we pass it through an activation function, and then we get the final output.
Instead of 3x4, can we have 4x3?
Well, then matrix multiplication won't happen, right? Because if we have 4x3, I mean, definitely, if there were 3 inputs and we had 4 hidden neurons here, then the matrix would be 4x3, right? But if you know, because you might have done matrix multiplication, so we know that the number of rows, if we are multiplying A into B, then the number of columns in A should be equal to the number of rows in B, right? Otherwise, we won't be able to multiply. So that is why it has been represented in this way.
Yeah, okay. Got this.
Okay. So any other doubts?
No, thank you.
Okay.
Thank you.
So moving on to the main part of the demo, we'll be first installing this library called GDown, because we are going to use an image dataset, as I mentioned earlier. That dataset has a lot of images of chest X-rays, and it's pretty huge. It's like 2.4 GB. So I don't want to save it on my local and upload it during the meeting. So I sent it to my cloud, and because even this is connected to Google Cloud, I'll be able to download it fast. So in order to connect to my Google Cloud and download that data set, I'll be using this library called GDown. And I am putting this exclamation mark here. Most of you guys might be aware that inside a Jupyter notebook, putting an exclamation mark is like running this command inside the terminal. This command does not run inside the notebook. It runs inside the terminal of where the notebook has been launched. So once I install GDown, GDown will give me a command line utility, and there I'll just have to run GDown and the drive link where my data set is present. So here you can see the file system currently. Now I'll just run this command GDown and the drive link. You can see it has started its download, and the file is being downloaded. This is the part file. So while that thing still happens, I would like to discuss how we perceive images versus how machines or how a computer perceives an image. So for us, an image would look like this, but in memory, an image is a two-dimensional array. Like it could be a three-dimensional array, but it's like a two-dimensional array of pixels, right? So every pixel has an X coordinate and a Y coordinate. And internally, that pixel, if it is a grayscale image, a grayscale image can be represented as just the intensity of whiteness or blackness, right? A number between 0 and 255. Or if it is an RGB, that pixel would be represented further as another tuple of like 3 values. The first one being a 0 to 255 intensity of R, the second one a 0 to 255 intensity of B, and the third one a 0 to 255 intensity of G. Or wait, did I say it wrong? Yeah, the first one red, the second is blue, and the second one is G in case of some libraries, and some follows the first one as red, second is green, and the third one as blue. So RGB or RBG, whichever one. Matplotlib of Python, it follows the RGB structure. And then we have, I think, Pillow, which follows the RBG structure. So we'll be using Matplotlib and we'll be using the RGB structure here. Although it does not matter because X-rays are going to be black and white anyways. Yes, so we have the zip file here. It has appeared. You can see the download has completed. Now I'm going to unzip it using this this command line utility unzip. It is pre-built inside Linux, and I'm using this flag QQ because unzip, whenever it unzips one file, it extracts one file, it will give me a log, and I don't want this notebook to be flooded with 1500 or 1600 logs. So this one will force it to keep quiet and not generate any logs at all. So let's wait for the unzipping process. Once that unzipping happens. So till that time, do you guys have any doubts regarding this part, like representation of an image inside memory? Do you guys have any queries regarding that?
Pratik, we have a doubt from the previous theoretical session. What exactly is an activation function?
Okay, so then that activation function is a non-linear function. It just takes in an input and gives an output. It's just a transformation function, and we use it because the thing is, you saw here, right? What a neuron basically does is, if you just ignore this part, if you just ignore the F part, it is just taking a multiplication, a cumulative sum of the products of the inputs. So that is just a linear equation, right? If you multiply x1 by a coefficient and then you add it with x2 multiplied by another coefficient, we get an equation like y is equal to m1 x1 plus m2 x2 plus m3 x3 plus c. And this is a linear equation, right? But not everything in this world is a linearly connected thing, right? Especially these things like images and all, they are not at all connected linearly. There is no linear connection. That's the reason why we moved into AI, because the connection could be exponential and the relation could be something, way different than exponential. It could be inverse exponential. It could be a logarithmic relation. So for that, we use this activation function so that our model is able to, correlate data with even non-linear functions, with even non-linear characteristics. Is the doubt clear? I mean, we'll see a few of them. We'll see a few of those activation functions later down the demo and where they're used. So I think, yes, the extraction has completed. You can see this chest X-ray folder has been created. And if I open it, this Mac OS X, and this is for like Windows part of the thing. That's how it has been zipped. And if we see the part where Linux is concerned, we have three folders here, three main folders here. We have test, train, and validation. We'll see what all of those folders mean and why we need them. And each one of them has two folders. One is normal, one is pneumonia. So within normal, we have images, we have a few JPEG files, and each one of them represent the image of a normal lung chest X-ray, and this is for a mnemonic lung chest X-ray. So we have quite a few of those images for the training part. Let me see if I can open one of them directly. Otherwise, we'll be seeing it anyways on the next slide. Okay, I think I need to zoom out a bit for this. Okay, that image itself is big enough. Yeah, so you can see this is a chest X-ray image here. This is a normal lungs chest X-ray, and if I open the other one, now I'm not into medical science and I don't have any idea about whether this is a normal lung or not. I'm just trusting what the data set has been provided to me by the hospital. So this is a mnemonic lungs chest X-ray. Okay. So after that, what I'm going to do is I'm going to store their paths, the path of the training folder inside a variable, the path of the testing folder inside a variable, and the validation folder inside a variable. We'll need them later for a generator because we cannot load like all 256 GB, and it was 256 GB zipped, right? The original data set is like way huge. I think it was like 8 or 9 GB in size. So we cannot bring all of that into the RAM because it will slow our entire system then, and it will be a problem during the training process. So we use a generator in that case. How that will work, we'll discuss a bit later. And the train N, this is the normal folders path, and this is the mnemonic folders path. So after that, in this snippet, what I'm doing is I'm importing OS. Now OS is used to access these file path and file names. NumPy is a array library which is written on C and it has been ported to Python. So it is super fast. CV2 stands for OpenCV2, which is like Open Computer Vision Library for Python. It is used for image manipulation and a bit of object detection. And we have matplotlib, which is the plotting library in Python. So it can be used to, it is majorly used to plot graphs, but it also has the functionality of plotting images. Because we are in a cloud environment right now, I cannot if I click on this, it won't open an entire new screen for us to analyze the image. So I'll be using matplotlib to print the image here itself, like to plot the image as a graph here itself. You guys will see how it happens. So here I'm finding one normal pic. So I'm using NumPy's random, and I'm generating a random integer between 0 and length of how many images are there inside the directory. And I'm taking in one random pic from the normal directory, like within the train, we have the normal images, right? So I'm taking out one of those, and within pneumonia, there we have a few. So I'm taking out one of those. Okay. we have quite a few. I prefer not to open the other one, or it will slow down my browser. So I'm taking out one random normal image, one random mnemonic image, and I'm going to plot them out using on a grayscale map. So let us wait for the output. So yes, here we have the image. So this is a normal lung. This is a mnemonic lung. And we can see we have 1,342 images in our training set. And I would also like to print the shape. So this shape will give me the shape of this image, the image that we have brought down here. So you can see it has 1,638 rows, 1,870 columns, and it has 3 channels. Now channels is what we discussed here, this one. If it is a grayscale image, if it has, so it will need just one number to represent the intensity of the pixel. Whether it's, if it is completely black, it is 0. If it is totally white, it is 255. Or if it is an RGB image, it will need 3 of them. So that is the number of channels. If it is RGB, we need 3 channels, R, G, and B. If it is grayscale, we'll need 1 channel, that is just the gray value. So here we can see these images, although they are black and white in nature, they have been saved as an RGB image. So we have 3 channels here. And I have also printed the pixel values of the 0th column and the top 10 rows. I mean, the top of, not the top 10, I would say the first 10 pixels. And you can see the values, each one of them has three rows, right? Each one of them has 3 values. It's a 3-element array with the pixel values of R, G, and B. And because this is a grayscale, so all 3 of them are bound to be the same. So till now, till this point, does anyone have any doubts? Are you guys executing it side by side? I mean, it will help you guys a lot if you execute it side by side, you know.
Yes, we are executing.
Okay, so do you guys have any doubts still here up to this point?
I have a doubt.
Yeah.
As you said, white and black have different numbers, right?
Yes.
In between. So as per now, what I've understood is the computer, the AI tries to compare the images of the normal person and the patient, and looks at the numbers where white is more or less. Am I right?
Well, it kind of does that, but it does not do exactly that. Like that would be the case if we would use some statistical machine learning model, like, you know, SVM, random forest, something like that.
Okay.
But the AI that we are going to train now, deep neural networks, they don't just look at exact values. They will look for patterns inside those values. So they won't only see whether a particular pixel is white or black. They will look for like patterns, that whether a white pattern, what kind of curve of a white pattern is present, what kind of curve of a black is present. So they will look for more complex things because they are like such complex models with all of those interconnections, and then we have the activation function. So all of that will together allow our AI model to look for more complex patterns. And that is why these models are way more powerful than our conventional machine learning models.
Okay.
Okay.
Thank you.
Yeah. Any other doubts? Okay. I think we can move forward with the session then. Okay. Let's see. I think on chat something has appeared. Oh, okay. Fine. Okay. So now I'm going to use the Python library Keras for making the deep neural network. So Keras is a very popular library. Currently, the 2 most powerful, like popular libraries of Python are TensorFlow and PyTorch. And Keras, before that, it was like Keras was so popular that TensorFlow integrated itself, like Keras inside itself. So if you guys are using TensorFlow, or if you guys look into TensorFlow, you'll see that TensorFlow 2.0 is completely based on Keras, the newer version. It has TensorFlow.keras and everything is present, like all of this thing. You just have to add like TensorFlow, like tf dot, and all of this code will run in TensorFlow. But does not matter. We can just use the vanilla Keras for our purpose. And we are going to use, so from here, we are going to import a sequential model. Why do we call it sequential? Because it happens in layers. So we're going to first have an input layer. We are then going to have a hidden layer, another hidden layer. So that kind of, the data kind of goes in sequence, right? From one layer to another. That's why they call the model sequential. And then there are different, architecture of layers. Like each layer has its own work. Each layer computes in its own way. So we have conv 2D, convolution 2D, max pooling 2D, flatten, and dense. So we'll be going through like each one of them, like what they do. Till now, you guys have heard about only dense. Dense layer is basically this layer, the vanilla. Do we call it vanilla, or maybe we call it the baseline layer that we have seen here? It just has this kind of function built inside it. That's all. It does not have any special characteristics. Although the other layers have their own special characteristics and their own special behavior. Apart from that, we are also going to import a pre-processing thing. We are going to import image data generator and load IMG. Why do we need pre-processing? Is because these models, they internally, all of them have fixed arrays. And just a few moments ago, someone asked, why do we have a 3x4 and not a 4x3? That is because the inputs and the outputs, they have to be predetermined. We cannot change the length of an array in between and expect the entire matrix calculation to work properly, right? So in order for that to be executed correctly, we have to fix all of it. And that is why we'll need this image data generator and its pre-processing, because we have images of different sizes. Here itself, we can see this image is not as the same size of this. So we'll need that so that it can resize all the images to one fixed size without much loss in information. Like it will compress the image. It won't crop it, it will compress it. And then we need this metrics to just check like how well our model has performed, like accuracy scores and everything. We'll import it from another library called sklearn. Keras does not have good enough, accuracy checker. So we'll be depending on sklearn's one. So we'll be importing all of these. It will take some time to import. And then we'll move on with convolution neural network. Okay. So before we move on, I'll drink some water. If you guys don't mind. You guys can ask your questions in the chat box till then. Okay, fine. Yeah, sure. You can connect with me over on LinkedIn, GitHub, anything. Fine. So
Prateek is getting a lot of popularity, but to be honest, Prateek, the session is so awesome. Even I'm enjoying. I'm also doing right by right how you're explaining. So thank you. You can go ahead. Thank you very much.
Thank you for the compliment. Okay, so let's move on to the convolution neural network. So you guys can see here, right? It's telling me that I am on a GPU environment, but I'm not utilizing it. So the thing is, Colab by default does not have a GPU, but have configured it so that I can get access to the free GPU. I think all of you guys should do the same. You can go to runtime, go to change runtime type, and here you will get a drop-down menu. So it should be set at none by default. If it is at GPU, then it's fine. Or you can also get access to TPU, but that is an even more powerful device, handcrafted. Like that processor itself is like handcrafted for AI/ML purposes. But we don't need that right now. So we'll just leave it for people who need it more than us. So what happens in a convolution neural network is, this is the main part, as Harsh asked, like whether it takes in values or not. So we use convolution neural network to find patterns inside image. And how does it do that? So suppose you have an image, like suppose this blue matrix is an image, and for simplicity's sake, we are taking in ones and zeros right now. Let us imagine this is a black and white image. The zeros represent black and the ones represent white. In most of the cases, you will come across such images which are like that. So what it does is it takes a predefined matrix, so which is called a filter. That matrix is usually smaller than the image, very small compared to the image. It's usually 3 cross 3, 5 cross 5, maybe sometimes even 2 cross 2. And what it does is it will overlap itself with a section of the image, and it will carry out a element-wise multiplication. So it's a GIF. I cannot like really pause it. So you guys will have to see how it's going on. You guys have a closer, you can have a closer look of the GIF, which is there on your screen, on your notebook. So it carries out element-wise multiplication, and it sums up that element-wise multiplication. So what happens is, the higher the value, the higher is the similarity of that region compared to your filter. So this is where we get that property of pattern recognition. So I mentioned pattern recognition, like curve recognition, edge recognition, all of that. So all of that is done by this filter. So if the filter value is high, that means a lot of more pixels matched to that pattern. And if the pixel and if the value is low, that means it was not that strong, that pattern was not that strongly present in that region. And that is how you can find the resultant, from the resultant matrix, you can find out where exactly that pattern occurred in the image. So you can see here we have a 4 and here we have a 2. That means the top left of an image, the top left area of an image has a stronger presence of this pattern. The green pattern is present more strongly on the top left compared to the other regions. It is also present on the center, the bottom right. So you get the idea, right? And this is a kind of, okay, fine. Yeah, I included a still image of that. Yeah. So this is how that thing happens on a still image. It moves, it slides across the entire image, the entire length and breadth of the image, and it generates an output for us. So you can see this is how the multiplication happens. So this is our filter, this -101, -202, -101. And this is the big image we have. It overlaps itself with this. And we see -1 into 3, 0 into 0, 1 into 1, -2 into 2, 0 into 6, 2 into 2, and so on. And we get the result as -3. And this -3, it is stored at the center of this region. By this region, I mean the source region with which it overlapped, it is stored at the center of that. And that is why most of the kernel values that you would come across during your machine learning journey, you would see that most of them are odd length. Why they're odd length? Because we need a center to store the value. In case if it is an even length matrix, if it is an even length filter, then you won't have a center to, definite center to store your value in. Or if you have two options, even if you store in two places, you'll have to face that problem of overlapping. So there will be a lot of replacements and all. So we usually take for easiness and for simplicity, we'll take a odd length one. So up to here, do you guys have any doubts, like working of the convolution? Okay, my chat has
no doubts.
Okay, nope, understood. Fine, that's good. So now we'll start building the machine learning model step by step. So what I'm going to do is I'm going to call my model CNN. We could call it anything. We could call it A, B, C, model, anything. So we'll call, so first of all, we'll have to create an object of the sequential class. So the sequential class is going to be the core model. And we don't pass in any arguments right now. We don't need to pass any arguments, just the default one will do. Once that is done, we will start adding layers to it. So when we define a model, it's like an empty shell. We need to add layers to it. So the first layer that we are going to add is going to be a convolutional 2D layer. Now, why is it 2D and why is it not just convolution? Because convolution can happen, this kind of pattern recognition, multiplication, you guys might have figured out, it can happen in any dimension. It can happen in 1D, it can happen in 3D, it can happen in ND, does not matter. So we are going to use the 2D one because we are working with images. And then the first one, if I am able to bring up the documentation, yes. So you can see the first argument. So for bringing up the documentation, just put your cursor at after D and press Control Enter. And when this option appears, just hover over it, or you can just press Control Space again, and it will open up the documentation for you. So you can see the first one is filters, the number of filters that I want to pass. So this one is something that, now I would like to reveal this thing to you. It's not much of a secret anyways. These values like filters, number of nodes, number of layers, these are actually random. There is no rule of thumb, or there is no mathematical principle that will tell you what is the correct one. You will gain this power with experience and through experimentation. Most of the times it's experimentation. Like as you move on for higher applications, you'll notice that it has become more like experimentation. You'll have to change the values, you'll have to retrain the model, and you'll see which one gives the best accuracy. There is nothing like a best one for it. So approximately I'm taking 32 filters, like 32 different patterns. And then the kernel size. So kernel size is going to be the filters size, length, comma, breadth. So I'm taking a 3x3 matrix. And then stride. Stride is how fast that array will move over our image. If you see this animation, at any given time, this filter, it's moving one by 1 unit across the breadth, and then once it is done with that row, it is moving 1 unit down. So that is going to be the stride. If I would have set it to 1,2, then it would move like 2 elements at a time over the breadth and 1 element at a time over the row. Like once it is done with that row, it would move 1 row down. So this is the stride. I'm leaving the stride as it is. I'm not changing it. Then we have the activation function as relu. Now this activation function relu, what it does is, if the input is lower than 0, it will, convert it to 0. It will pass it, it will pass 0 as an output. If it is more than 0, then it will pass, something which is, it will pass the same value. Sorry, it will pass the same value. I think I can bring up, relu's, this thing, relu's graph. If I can bring up, yes. This is how relu looks like. So you can see when the input is below 0, it will pass 0 as an output. And when the input is above 0, it will pass the same value as an output. Now, why do we use relu? Because experimentally, in most of the machine learning applications, relu works the best. People have tried out various kind of activation functions. We have tanh, we have sigmoid, and we have a lot of custom defined ones too. But relu seems to work the best, so people are using it. As I said, you'll have to experiment. Whichever one works the best, you go with the flow.
Okay, Prateek, there is one question. Varshini is asking, how do we see this documentation? So if you can tell once again.
Okay, so for any kind of documentation, like suppose you want to take out the documentation of sequential. I mean, obviously the website is there, but apart from that, suppose you want to bring out the documentation of sequential, the place where L ends, before the brackets where L ends, just put your cursor over there and then press Control Space. So you will see the documentation of sequential will occur automatically. Were you able to bring it up? I mean, sometimes due to internet connectivity issues, it takes some time for it to bring up the documentation, but it will come out eventually. So like for conv2D, I just put my cursor after D and I press Control Space and the documentation comes up. And after the activation is done, I use all of that normally, like use bias. I want the bias term to be present. I don't want it to be completely dependent. I want that, C term, y equal to mx plus c. I want that C term to be present. So that is being passed as true, and the rest of it, we don't need to worry about it. And the most important one here is input shape. Why? Because when you create a sequential model, this input shape parameter, this is going to be passed only in the first layer. You don't need to pass it in the layers further down. If you see the layers further down, I have not passed input shape anywhere because Keras will calculate that automatically. But in the first layer itself, the model needs to know what kind of input it is going to get, right? So from the perspective of this layer A, it needs to know how many X it is going to receive. Otherwise, it won't be able to, create this array inside the memory, right? So we'll have to pass that input shape here as a parameter only for the first layer. After that, whenever we add another layer, Keras will automatically calculate it based on everything. Based on the previous layer, it will automatically calculate how much to allocate and what kind of array to create. So we'll run this and the convolution layer gets added automatically. Another thing you guys might have noticed, the input shape here is 64,64,3 because I'm going to pass in an image. At a time, I'm going to pass in an image of length and breadth 64,64, which will have 3 channels because our images were of 3 channels. But then our images were not 64,64, they were of various sizes. And we are going to handle that using image data generator. This image data generator is going to automatically convert. When we are about to give the input, it is going to automatically take in our input image, no matter what the size, it will convert it to 64,64. Then the second layer we have, which we imported here, was max pooling 2D. So now that we have a matrix like this, which tells us the strength of, the presence of a particular pattern, we want to take out even, a more global kind of, observation, a more global insight. Because at the end of the day, all of this is going to converge into like one particular point. All of this array, it is going to converge to one yes or no question, right? So even though we have these kind of insights that, okay, here we have this pattern, here we do not have this pattern, we want to take a more global, we want to just worry about those pixels where that pattern is present. We don't want to worry about the other pixels. And that is where max pooling 2D comes in. Max pooling 2D, why is it 2D? Because it's going to be applied on a 2D matrix. Max pooling 1D is also present, 3D is also present, and ND, you can make it if you want. So what it's going to do is, similar to how our convolution layer had, selected a region and multiplied it to a filter, what max pooling 2D is going to do is it is going to take a region. It won't have any auxiliary filter which is going to multiply with. It's going to take a region out of this resultant matrix that we are getting, and it is going to take out the max value out of it. That's as simple as it. So what happens actually is, it takes in a region and it finds out what is the maximum strength of a pattern in that region. So you can see here, I'm going to use a 2x2 filter with a stride of 2. We remember strides, right? From this convolution 2D, I had discussed that we had this parameter called stride. So here the stride of 2 is visible. So it will take this region and then it will move itself by the region being concerned, will be moved by 2 pixels. So this region, and after that there will be no overlap. It would be then considered as this region. And even when this row is completely like processed, the row movement will again be the Y movement. The direction in Y would be moved by 2 pixels again. So that is why the stride is 2. Actually, this should have been 2, 2, but yeah, it's just written as 2 in this image. So it will help us to generalize our results even more. So here we are doing the same max pooling 2D. We are going to do CNN.add and we are going to do max pooling 2D, pool size 2, 2. And I'll open the documentation once again of max pooling 2D for you guys. So you can see we have pool size 2, 2, that is the default one. And then we have strides none. So if you read this thing further on, you will know that strides none basically does a stride of, I think, 1, 1. Well, that is a thing of the documentation. We don't need to worry much about it right now. And this does not have an activation function because what it's basically doing is it's just finding out the maximum. So we don't need an activation function here right now. And now that we get this matrix, this maximized matrix here, we are going to apply another layer of pattern recognition inside it. Because if you think from a brain's perspective, we don't identify everything just on the basis of, simple lines and curves. If I ask you that, okay, this is a cat, this is a dog, can you tell me the difference of them based on simple lines and curves? You won't be able to answer it, because your brain is trained to identify the entire thing at once. It will see the entire cat, entire dog. It has a pattern for that entire creature at once, right? And this convolution layer stacking is what allows us to do that. So now that we have a pattern map, a maximized pattern map, we apply pattern recognition once again on top of that. So the more number of times you do it, the more complex patterns your model is able to identify on top of each other. And then we are going to add another max pooling on top of it. So this is going to be like this is going to be the pattern recognition part of our model. So till here, does anyone have any doubts? Okay, I'll take a look at the chat. Okay, no, understood, fine. Now we'll move on to the third layer that we had implemented, which was called flattening. Now, why do we need flattening? Because I'll once again go back to this image, because the inputs have to be in a single dimension. We cannot have like this multiplication. Each element has to be a singular element. It cannot be an array inside another array for matrix multiplication to happen properly. So what we do is, once we get this maximized array, so at the end of this max pooling 2D, we are going to get another two-dimensional matrix. What we are going to do is we are going to just flatten it. So flatten does not have a 2D, 3D or 1D addition, no matter whatever kind of data you pass to flatten. And it does not even take any argument. So whether you pass in a 3D array to it, whether you pass a 2D array to it or a 1D array to it, does not matter. It will flatten it out. It will extend it out to a single dimension layer. And that thing, once we have that single dimension layer, will pass it on to an artificial neural network, the network we defined first. And this is up to this part, this was just pattern recognition, right? And this dense network, this dense neural network, this is the part where the main decision-making process happens, the weights, biases. This is the one which is going to have the maximum impact. This is where the main learning happens. So we are going to create a simple dense neural network with 128 units. By 128 units, I mean 128 neurons. And at the end, we are going to have one neuron, just one unit. And why do we have it? Because our answer is going to be of the type yes or no. So it should either pass out a 0, because 0 is like, zero denotes false in most cases. So 0 for false or 1 for true. So we are going to do that, and we are going to pass an activation of sigmoid. Now, what is sigmoid and why do we need it? So I'll just open sigmoid in a Google Chrome tab. And here we have sigmoid function. So you can see here, sigmoid function, what happens is, if it has a value less than, like if the values are less than 0, if it goes up to, minus infinity, even up to minus infinity, does not matter. It will kind of, how do I explain it? So this is a constant function. It does not depend like relatively on the entire array. This is like, it takes in just one input. The range does not matter. So whatever value you pass to it, it will round it off. It will do an exponential round off between 1 and 0. And we are looking for a model which gives us either 0 or 1 as an output, right? We are looking for either a true or false kind of output. That is why we have to pass it through a sigmoid activation. So the sigmoid activation, no matter whatever value our neural network is giving, whether it's giving minus 10 lakh or whether it's giving plus 10 crores, does not matter. It will scale it down to 0 or 1. And that will help, and that will make it easier for us to analyze the output. And if you guys want to see how it does that, so we have sigmoid's formula written here. So if you guys put, no matter whichever value you put here, X value you put here, this value will always range between 0 and 1. This 1 plus 1 1 by 1 plus e to the power minus x. Okay, something is here. Why not SGN function? Okay. What exactly, wait, I'm not sure what exactly SGN function is. Okay, wait, I think I have read SGN function somewhere in my first year. Oh, okay, why not this function? Yes, we can use this, but the thing about SGN function is because this function does that approximation so sternly. So what happens here is if we have some minimal kind of error, because this is going to be, the output is going to be a confidence value. Okay. So a bit wrong on my part, it does not actually, like sigmoid will return a value between 0 and 1. It will not return just 0 or 1 as an output. It will return a value between 0 and 1. So that will be the relative confidence. 0 means like that person is completely normal. 1 means a person is like completely mnemonic. Like there is 100% confidence. The machine learning model is saying I am 100% confident that this is a mnemonic lung. In most cases, it does not do that. In most cases, it will give you a confidence value. Like I am 60% sure that maybe this person has pneumonia, or maybe I'm 30% sure that this person has pneumonia. It will pass out something like that. And that confidence is what we need, because that confidence value will allow us to better fine tune our model, because we don't need that kind of stern error like 0 or 1. That is a very stern kind of error value. And when the model tries to optimize itself, when the model tries to, learn from its mistakes, when those high kind of errors are coming in, the model's change in weights will be too big. And the model's, accuracy will keep jumping around. Once it will go very high, then it will go very low. However, if you use these fractional inputs, the model will know that, yes, I am gradually moving towards the output. I'm gradually moving towards the, range where I want. So earlier it will have a very high, change of values, but then eventually that curve will smoothen. I think we'll see that here, or maybe not, because this one is going to take a long time. I'll definitely show you guys an example of how that accuracy changes. And okay, wait, I see a lot of chats. Understood. Okay, mod sigma. Okay, fine. I think I got the right function. And then finally, once all of these layers have been added, I'm going to call compile. So this compile is going to allocate all those arrays inside our memory. It's going to generate all of these arrays, because all of these need some array storage, right? We saw it here. These W arrays, the B array, all of them, they will be initialized randomly at first. They will have all random weights. So all of that will happen once I call this compile method. Where did it go? Yep. And while compilation, I'm also passing optimizer, and I'm also passing loss and metrics. So let's first, execute it, and then we'll go over what these mean. So optimizer. So if you give a model just this, data that, okay, this was your input, this were your weights, and this is the error you got. I compared your output to the known outputs, and this is the error you got. There has to be some function which will tell the model further, like how to optimize itself, right? How to make itself better, how to learn. And that is what optimizer function will do. This optimizer Adam, this is one of the algorithms. We have other algorithms too. You can go towards genetic algorithm if you guys want. That is a completely different architecture though. Within sequential model, we have RMS prop, we have ADAGRAD, we have stochastic gradient descent. You guys can check those out. Optimize, why I'm using Adam, because Adam works well in most cases. Again, another experimental result. So this Adam, what it will do is it will look at the weights that are present. It will look at the kind of error the model has caused, and it will tell the model how to tweak its weights, how to change its weights and biases so that it moves closer to the function, like it moves closer to the real value, so that next time the prediction might be even more accurate. And that is done by differential mathematics. It's done using differentiation. You guys can check out back propagation and gradient descent if you guys are interested. And you guys can also solve out a few examples if you want to see exactly how that happens. And then we have this loss, binary cross entropy. So although we have outputs and we have the predicted outputs, someone has to tell the model, like some algorithm has to tell the model how to calculate the, what do I say? How to calculate the error, right? Because for different kind of tasks, we are going to have different kind of errors. Suppose you have the task of, predicting the house prices. In that case, your error would be MSE, mean squared error, or maybe you can just use squared error or mean absolute error, does not matter, whichever one. But because we are doing a classifying task, so the outputs are going to be yes or no. So we have to count the number of misclassifications here. Just counting the subtraction of it does not really make sense. Although subtraction would make sense. What binary cross entropy will do is, we remember we have sigmoid as the output. So this won't be returning either 0 or 1. It will be returning a fraction. So what binary cross entropy does is, if it is less than 0.5, it will round it down to 0. If it is greater than 0.5, it will round it down to 1 automatically, round it up to 1 automatically. And then it will find the difference and tell the model what kind of error it has caused. And then we have metrics, because the model will need a target. The model has to work on a particular, the model needs a particular direction to work on. It needs an aim. Just if we tell that model, suppose you're giving an exam. So in exam, you have a target to earn more score, right? To earn higher score. That is your aim. Otherwise, another matrix could be, suppose I tell you that your score does not matter. Just try to make lesser mistakes. So that could or could not guarantee a higher mark, right? If you're, suppose you have some 10 questions of 1 mark each, and you have another question of, 10 marks. And if I tell you that try to make lesser mistakes, either you could, only answer the things that you're confident about, or you can be very intelligent and not answer the question at all. No question answered means no mistakes made. So based on that, we'll have to give the model a direction to work on, a metric to improve. And that is why we are using accuracy. We are telling the model that test everything out and try to improve your accuracy as much as you can. So up till here, up till compilation part, have you guys executed? And do you guys have any doubts? Or did any of you guys face any error in between? Okay, let me keep the chat box open just in case. Guys, you can write in the chat box if you have not faced any error. Okay, everything working fine. So any doubts regarding what we have discussed till now? Okay, fine. I think we can move ahead. And now that we have done all of this, we have compiled the entire model, we can get a summary of the model. And this will help us visualize what kind of model we have made and how many, weights and biases are present in every matrix. So this params, you can see here, I have printed model.summary, CNN.summary. It tells me what kind of layer is present, a name for that layer that it generates automatically, the shape that it's going to be. Remember that this is the only shape that we had passed. Okay, hold on. I think there is some error here. There is some mistake on my part. Okay, no, yep, fine. So here we have this thing, the shape that we had passed here, 62, 62, 32. Although I'm not sure why it is acting like this. It's supposed to be 64. Okay, fine. I get it. Okay, that was the input shape. This is going to be the output shape of it. So that 32, 64, 64, 3 merged with 32 filters would give me 62, 62, 32. Like this is 32 is the number of filters. And this is the number of trainable parameters, the number of weights and biases that are present inside it. You see a lot of chat inside it. Google Colab link. Okay, fine. And then we have the max pooling. Then we have another convolution max pooling. And you can see, as I said, it does not have any weight or biases or activation function. And that is why the trainable parameters in max pooling is 0. It does not take anything. Same applies for flatten, because it is not doing any computation, and just like normal reshaping, it has 0 trainable parameters. And then we have a dense layer. And then we have, wait, hold on. This is weird. Okay, fine. I think I messed up a little bit. I executed this block twice. So you can see it tells me that after this dense, we have another flatten, and then we have another few dense layers. So I'll just reconfigure my model. I'll run it from here. So I redefine it. Then I add these layers. Oh, wait. Please don't tell me I think it just reinitialized the entire thing, or did it just clear the output? Okay, fine. Everything is fine. Okay. I pressed something. I pressed the shortcut to, clear out all the outputs and merge all the cells. So I'll just show it to you guys again. Everything will work fine, I hope. Okay, up till here, everything is working fine, means all of it will work fine. Yes, so now we have this model, you can see. We have flatten, and then we have just 2 denses. So the total number of trainable parameters, weights, biases included, there are going to be 8,13,000 different elements that after every epoch, this model is going to modify 8,13,000 different kind of elements. Like, different numbers which are present inside it. And then these are number of test samples, and batch size. Will come to what is batch size a bit later. Now, image data generator. Why do we use it and why do we need it? Right at the beginning, I had told you something about the size of the model, right? Okay, wait, hold on. Do you guys have any doubt regarding this thing, like the summary diagram? Okay, yeah, it would, because you ran it correctly. I ran 2 statements. I ran the first statement twice, so that's why it was showing that many times. Fine. Okay, so right at the beginning, I had said, like, we cannot load usually these big data sets. I mean, this is still a small data set compared to like machine learning stuff I have worked with. This is still a very small data set, 2 GB. We usually work with data sets which are even greater, like 40, 45 GB in size. Some even range to terabytes, like stuff which happens on videos, like training on videos that has terabytes of size if it's high definition videos. In that case, there is no way you can load everything into the RAM at once. And that is where generator comes in. So generator is a special object which does not load everything to RAM, but it keeps a track on the folders where data is present. And every time you call it, it will dynamically go to the directory and it will fetch parts of that data and it will bring it to the machine learning model. It will not bring all the images at once, otherwise it will. Okay. I think I heard recording stopped.
Yeah, I'm just resuming.
Okay. Okay, fine. So the thing is, it will go there and it will dynamically fetch in data part by part so that our RAM does not, get overloaded. And we do not, mess with a lot of data at once. So image data generator, it is a special kind of object provided by Keras. And for using image data generator, our folders also have to be in a particular structure, in a particular shape. And it is going to be in this shape. This is going to be the main test folder. It should have 3 subfolders: train, valid, and test. And within them, train, valid, and test, each one of them should have a folder representing one of the classes. And those folders, okay, and within that, each folder will have the images related to that class. So I had shown you right at the beginning. Here we have the main data folder. We have test, train, and val. And within them, we have the class folders, normal and pneumonia. These are the class folders. And within these respective folders, we have the images pertaining to that class. So we define image data generator first. So we'll have to create 2 different data generators. We first define image data generator, and then within that we'll pass down some arguments. So image data generator not only loads data, it can also configure that data before we pass it down to the model. So you guys remember this part, right? Where I had passed input shape as 64, 64, 3. And I had said that we would resize each image to 64, 64, 3 before we pass it down. So that thing is going to happen here. Like all of that is going to happen here. We are going to first rescale the image because 0 to 255, they are big values. And that would again put stress on the model. And when we mess with big values, as I said, we use sigmoid activation function for a reason. When we mess with big values and big errors, the model tuning is not very good. Like the change of weights is very haphazard. So we divide it by 255. And then we also define these parameters. They are used to randomly put, in order to create a generalized data set. We don't want the model to, memorize our data because our model has like 813,000 parameters. It has the capacity to almost memorize data if it wants to. So what will happen is during the training phase, it will be like, fine, I can get you 90% accuracy, but the moment you give it some data, which is like, which it has not seen earlier, the accuracy will be horrible. It will drop down to maybe 60, 70%. That problem is called overfitting, where your model starts memorizing the data. So we'll add these things so that the data that is coming into us, it will have some random transformation. So even though the images are not that high quality or something, our model trains well to face even those situations. And horizontal flip is true. This is another one. So it will randomly, sometimes it will not horizontally flip, sometimes it will horizontally flip. And then we take that generator object that we had created, and we would link it to a directory. As we had said, we will link it to the train folder. So train folder points to this folder. Remember, we stored a string path. So it points to this folder. We will link it here. We will say that the target size of the image should be 64, 64. So resize the images down to this part. And batch size is 32. So batch size is basically how many images do you want to load into the data set, into the model at a time. So that will be 32. And class mode is binary. So this could be binary. This could be like something else. I'm not sure what the other one is called. I think the other one is called sparse. So currently we are classifying things into either a yes or a no, right? But suppose there is another popular data set called MNIST. It has images of digits, handwritten images of digits from 0 to 9, like 10 different classes. So in that case, the class mode would be sparse, because we are working on classifying data set, classifying the image into 10 different classes. Or I think it's called multi-class. I'll have to check the documentation for that. You guys can figure it out yourself. For now, it is binary. And we define the same for validation and test. So I'll run these. And you can see it goes into the data set and it just counts. It does not load it. You can see here on the RAM usage is still like 1.18 GB. So it has not loaded anything into the data set yet, into the RAM yet. It has just seen how many like images are there inside each the folders. So do you guys have any doubts still here, like up to image data generator? Okay, let's see the chat. Okay, no doubts, fine. Okay, so now once this is done, we'll move on to the main part. Now this is the final part. This is the climax of the entire thing, entire session. We move on to training. So we have an animation describing the training process here. I'll come to the animation later because this is going to take a lot of time. So I'll execute it first. And let's execute it first and we'll discuss what is happening here. So what I'm saying is I am telling it to fit on generator. So CNN has two methods. One is called fit, another one is called fit generator when you want to train the model. So fit would be used if you have your entire data set into the RAM ready-made, you will pass out the entire data from a variable. But if you have a generator needs different kind of handling to fetch the data, right? So in that case, we will use fit generator, and then we'll pass down the training generator as the first argument. And then we have steps per epoch. Now, if you guys remember, I had passed batch size as 32, right? So at a time, okay, what is up with the chat? Fit transform. Okay, fit transform is a different thing, Abhishek. Fit transform is used for, it is used for pre-processing stuff. So for model training, it's not fit transform. It's usually fit and fit generator. Fit transform will be used in pre-processing models where you want to, fit your model with the data and transform it at the same time. So I have not used it here because we are not doing any pre-processing here, but we have, when we do scaling, normalization and stuff, when you guys deal with different kind of data sets, you will come across that. It's present in sklearn and all. So because I'm fetching 32 images at a time, I want it to go into the directory and fetch this set of 32 images 163 times so that the entire directory is covered. Okay. So that is steps per epoch, so that the entire directory gets, brought inside our testing phase, inside our training phase. And then epochs, this epoch is going to be one forward pass and one backward pass. What happens inside that, I'll come to it later. So I'm telling it to go through 50 epochs, and then we need a validation data. Now, why do we need a validation data? Because I had said, our model has the capability to memorize stuff. So we need a part of data just for our, keepsake, so that we are 100% sure that our model is not, memorizing stuff. We store a part of data with us, which the model has not seen during the training. And at the end of every epoch, what we are going to do is we are going to send that to the model, and we are going to check what kind of accuracy does it have, whether the accuracy is increasing or decreasing. Suppose you have an accuracy of like 90% on the training set. On the training data, your model goes to 90, maybe 95, or maybe even 100% accuracy. But on the validation, you get very bad accuracy, like 60 or 70. That means your model has started to memorize stuff. So in that case, you will have to take extra steps to stop it from memorizing things. You'll have to add, more data. You'll have to add more variety to the data. You may have to add dropout layers and everything. And then we add validation steps as to like in how many steps the validation has to be done. So validation also has a batch size of 32. And I want the validation to happen multiple times because I think the validation folder has very few images. If I'm not wrong, yes. So in this case, if like one or two things go wrong, we might get misleading results. So just in order to, be totally sure, we perform a lot of random experiments. You guys might be aware of that paradigm, right? If we perform a lot of random experiments, we have a greater confidence level. We are more sure of the value that we are getting. So that is why we add a lot of validation steps just to be sure that whatever validation accuracy we are getting is 100% right. I mean, not 100% right, like we increase the confidence level. So this is how the training process will go on. You can see the accuracy is gradually improving. I'll just hide this thing. So at first we had an accuracy of 83% and the validation accuracy was 93, which is a very good sign that our model is not actually, memorizing anything, but it's rather learning the features that are actually inside the image, and it is learning them well. And then the accuracy starts increasing gradually. We have 90, 91, 92, and this will go on for quite some time. So we have 163 steps of training going on. We have like, here you can see the number of epochs that are left and the time left for the completion of this epoch. So this will take it will take quite some time. I think maybe 20 or 25 minutes to train. That's the problem with big data sets. So I think, yeah, that's is all from my end. So do you guys have any doubts? So with this, I'd like to conclude my part. So now we can move on to a like general discussion. So do you guys have any doubts? Did you guys face any errors or anything? You guys are free to discuss that now. Okay. Am I audible? Can someone confirm if I'm audible?
Yeah, you're audible.
Okay, fine. Fine. No doubts. That's strange. So would you like guys to discuss something like, how to move forward or anything? Like you guys can go for, like you guys have this data, so you guys can go forward and explore, from here on, you can go forward and explore like more data sets. And then you also have TensorFlow and PyTorch. You can check out PyTorch too, because PyTorch is more like research oriented. So everything that is recently coming on for the past 2 to 3 years, everything that people are developing, the code implementation of these research papers are primarily in PyTorch. People use TensorFlow only when big organizations go for production level stuff. For research oriented stuff, if you want to keep in touch with latest models, latest techniques, can I get your mail ID or WhatsApp number if possible? If anything related to study AI and I can reach you. Yeah, sure.
Everybody needs it now, Prateek.
I think I'm free.
Prateek, we will public it. What do you say?
Can you give a gist of how you got started and you're exploring about deep learning or AI? Okay, fine. So my journey goes back quite a lot. I started back in first semester. So there, because my specialization itself is AI/ML, so I thought like, why wait for third year? Let's start now. And it was a pretty hot field at that time. Like everywhere you go, all companies are like AI/ML inside our pipeline, this, that, AI is future. So I started with that. So there I first came across this thing, like I would say YouTube videos was the first thing, like Free Code Camp and all. They were there. Then there were some individual channels. I say Machine Learning with Phil. Then we have StarQuest. So those were there. So at first I explored statistical machine learning models, because until you get a good grasp on that, deep learning will not be, you won't be very much in sync with what's happening in deep learning, unless you realize the problems with that. And after that, what happens is, after I'm done with exploring that, I then moved on to deep learning. So I first came across Keras. For machine learning, I used scikit-learn. That is a very good library for that. The documentation is fabulous. You can literally learn everything about machine learning from the documentation itself. And after that, I came across Keras. Keras, I did not go much into the details because the documentation is not very helpful. Same applies to TensorFlow's documentation. From understanding point of view, it's not helpful. So you have to refer to like online tutorials and stuff, online videos to explain you how backpropagation and all happens. And yeah, then I kept on exploring into different fields through, because I was member of teams and clubs, they usually gave me work to work on AI related stuff, participating in hackathons. Hackathons really appreciate AI related stuff. Like any product, you put AI inside it and that product becomes valuable. So for that, I built some projects related to AI/ML, and yeah, by doing that and then reading, like currently I'm in the phase where I'm reading like new research papers and implementing them, like the research papers that are coming into new journals. In the last year or so, I'm working on using those. And what is loss in the compile of neural network? So loss is what helps the neural network to realize what kind of error it has made. So it gives a metric to that AI, like suppose you're giving an exam, the difference between the highest mark, that is 100, and your mark would be your loss function. It will tell you how bad you have performed. And it differs from model to model. It differs from, it differs from model to model, it differs from task to task, because we are doing binary classification here, and it is a comparison of yes and no. So we are using binary cross entropy here. If you were doing a multi-class thing, that would be sparse categorical cross entropy or cross entropy, just categorical cross entropy. If you are doing regression tasks, something like detecting prices and all, then it would be, I think, MSE, or even MAE is allowed in some libraries. Scikit-learn and Scikit-learn MAE is there. I'm not sure if it Keras has it or not. So that's what loss function does. It is a function which tells how bad your model has performed. It gives a measurement of that. It takes in, its arguments are basically, it takes in your model's predicted output in one hand and the original, the original to be output in another hand. So it has the solution key and your key and your answer sheet in two hands, and it tells like how bad you have performed. That's all. So apart from that, any other doubt, like apart from the loss of compile? And yeah, I mean, email address and all, I think you guys can share my WhatsApp number. I don't really mind, unless it does not go onto the live stream, because live stream it's going to get to the world. So I think you guys, I'll post my number in the group. I think you guys, all of you are a part of participants group. I'll post my number there. You guys can contact me there, or maybe on LinkedIn or email, whichever.
Now onwards, even I'm going to disturb you, Prateek, a lot for wherever I am stuck with my models. I will have one contact detail for that. So thank you very much.
Yeah. So yeah, guys, like let the model train. It will take quite some time. Yeah, you guys can just leave it like that. It will automatically finish its training, and after that you can check out this thing, cnn.predict, and then you can pass an image inside it as an argument, like an image array in the format that was passed. Because yeah, make sure another thing, like the model will take an input in only that format in which it was trained. So we are currently training everything in 64x64,3. So that is the exact kind of input you have to give for predict, and this will give you out the confidence value. One for like totally it's 100% sure it's a mnemonic lung, and 0 for if it's not a mnemonic lung, like it's a totally normal lung. Okay, so I'll stop my screen sharing now. So yeah.
It is actually indeed a very enlightening session for all of us. It was really great to hear from you, and it is giving all of us a lot of insight into AI and deep learning. And this is in fact one of the best sessions that we've all had. So thank you so much for coming after because you have invited. Thanks for coming. And our thanks extends to our wonderful media partners, VITrendz, innovation partners, Microsoft Innovation Club, space research partners, SEDS Antariksh, education partner, Edu Checked, and our fellow coordinators from IEEE BMSCE. And finally, our major host for this national summit, team behind Checked It. We extend a special mention to Yashaswini, Vice President of Microsoft Innovation Club, for her wonderful support. Thank you, everyone. And don't forget to join in for tomorrow's event on a panel discussion on disruptions by AI, moderated by Dr. Susan Elias, Dr. Ambika Diyar, Mr. Vinay Rao, Mr. Anil Srinath, Mr. Sayush Bhatt, and Shashwat Panda, our student representative. Thank you guys for joining in.
Thank you, Karthika. Thank you very much for that. May I please request Achyut to please share his screen and present the memento to our dearest, and I can proudly tell it, Prateek, this was one of the best sessions of these 8-day summit. Trust me, because I was able to interact lively. I was able to see that, and I'm so grateful for that. Give me a minute. I'm so sorry, but loved it, Prateek. Literally loved it, and personally, I learned something new today. So I'm
thanks
so
a lot
happy.
for giving me the opportunity. Like
You know,
I'm
this
actually
is
like quite not used to this, like taking a session and all. But thanks for giving me the opportunity to do this. It also
you know, there
boosted
is
my
one more person whose name I cannot miss, and that is Yashaswini. So Yashaswini, if you can please come online and show your face to the crowd, because everybody from yesterday wants to know who is Yashaswini, and let
Okay.
them know this. Because Yashaswini, this was never a possibility without you. And, you know, that is why we have specifically mentioned your name today in the vote of thanks as well, because we wanted to thank you, because this was not possible without you, and Prateek, you killed it. Like I'm
Totally
like
agree.
just, oh my God, it was so great,
Yeah.
so great. And please accept this from our side, Prateek.
Yeah,
As,
thanks
as
a
a
lot.
token of gratitude, you know, we are extremely thankful for that. And
I would
extremely
personally
thankful.
like to thank Yashaswini too, because like this entire thing, I was so nervous, and she just completely like kept on
Yes.
encouraging me. Even like 10 minutes before, I kind of had a panic attack. I just called her up. She kept on encouraging me, like
You know,
you'll do
even
great.
Yashaswini told me that you were panicking a lot, but then you killed it, Prateek. Now, next time for any of our event, you are the core keynote speaker. Now there's no going back from today's event. And again, yeah, once again, Yashaswini, thank you very much. It was like wonderful to have Prateek with us, and trust me, whoever was actually doing it and was listening to the session this is going to be one of the best sessions of the 8-day summit. So thank you once again. And maybe if Prateek, if it's done, should we end the meeting and also wind up the YouTube live? Or,
Okay, let me share the feedback form.
Yeah, please share that. Guys,
Yeah, from my
today's
end, it is totally done.
anyone who is filling for today's feedback form, it will be counted twice, okay? For 2 sessions, because that is what the impact Prateek session has made. So we will be giving a perk to all those people who have actually attended it. So we will be counting it twice. Your name will be counted. So if you have attended today's session, your attendance will be counted twice. So now no worries, folks. And also make sure tomorrow, there are some people from Silicon Valley joining us. There are some people from UK joining us. UK entrepreneurs are there. Make sure you are attending that event, and make sure we are having a fun learning time together. Tomorrow, there will be a huge Q&A session. You will be able to put forth your queries in the front of industry leaders. And on Sunday, we have a vice president HR of one of the biggest multinational companies in the world. And she will be also joining us for a non-technical session, because we have seen there were a lot of technical sessions, and people were actually asking, we need something non-technical because it's going above our heads. So we have planned this session, and she's the vice president of HR in that multinational company. And I hope you will have fun. And followed by that event on Sunday, again, we will have our lovely session with from our Susan ma'am, none other than Susan ma'am from VIT Chennai. And she will be giving a session on federated learning from basics, and how there is a huge requirement of this particular field in the industry. We'll be learning about that. So make sure you are tagging us with that. And do not miss about panel discussion. That's going to be the heart and core of the 8-day summit. Make sure you are. Yashaswini, any final words you have?
No, you guys are doing an amazing job. Like, kudos to you guys. Like,
No, it's all a team effort. Nothing was possible without this team and
but the
collaboration.
initiative itself is a great thing from your side. That's what I would say.
Thank you. Thank you very much. And Prateek, everyone, even Karthika, you did a splendid job. I cannot thank you, but this thank you, we will keep it for the final day, day 8. Okay, on Monday, whole team will be there with us, and we'll have a valedictory graduation ceremony kind of stuff. So we'll keep it that day. But thank you, everyone, and please let me know if we can close the event. So should we, Prateek? On Prateek's remarks.
I mean, from my end, it's done. Like people can now explore it themselves.
Yes, they will definitely, and even I'm going to explore it now. So
be a fun journey, guys. You do explore it a lot. So yeah, from my end, you can.
Okay, great. Thank you very much. I'm pausing the recording.